Welcome, everybody. Good morning, good afternoon, and good evening. My name is Asma, and I'm the community builder here at Encora. And we are going to talk today about edge computing. The following session, edge computing, is going to be taken by Mr. B. Ashok Kumar. Mr. Kumar is a DevOps engineer with 5 years of experience in the IT industry. His main focus is Azure DevOps for the past 3.5 years, and he's an expert in using Azure Pipeline for CI CD, managing source code repositories like GitLab and GitHub, and containerization using Docker. He also has experience with static code analysis using SonarQube, and in terms of infrastructure, he is skilled in using Terraform and ARM templates. Edge computing revolutionizes distributed computing by placing computational resources and data storage at the network edge. It enables real time processing, reducing latency, and enhancing efficiency. This abstract explores edge computing's architecture, benefits, and applications across Internet of Things, autonomous vehicles, smart cities, and industrial automation. With edge computing, organizations achieve low latency decision making, real time responsiveness, and data control. Now, I leave the floor to Mr. Kumar to go ahead and engage with you and do the talking. And I just wanted to remind you that you can all follow us in our social media appearing on the screen. And this session is part of the Global Development Week organized by Encora. And you can use the chat to leave comments, ask questions to the speaker. So I leave the floor to you, Mr. Kumar.
Uh, Thanks, Asma. Thanks for your nice introduction, and a great welcome to all the participants. And it's a great day, good day out. And here I'm here to, yes, sorry. Myself, as Asma said, that I'm an DevOps engineer at Encora, having the 5 years of IT experience. And as Asma has already given my introduction, there is nothing much to say about it. Yeah, coming to this session, so yeah, I'm going to take the edge computing. This is a session where we discuss about we have the agenda like this, like whatever the introduction we have, and coming to the evolution of the computing, and next followed by the architecture of edge computing. And moreover, when we discuss about the architecture and evolution, definitely we need to look about the computing challenges too. So which will help us to come out of the make the appropriate decisions or bringing all the things on the closure, and we can overcome the challenges. So there, and let's see about few case studies too on the edge computing, as well as what are the future trends in the edge computing. And this is the whole agenda when we come on to the session. So I think let's move on to the session. So fine. Let me go on to the introduction here. So what is edge computing and how we can, what is the importance of edge computing here? Let's discuss it. So, edge computing. It is a distributed computing paradigm which brings all together of the resources and come which will help the end user to work with the resources very closely. So the definition will come into like picture like this. Edge computing is a distributed computing paradigm that brings data processing, storage, and analytics closer to the end user devices. So nowadays we have a n number of devices we are using. So if suppose let me take an example, we are using a mobile, and when we try to reach out any other resources through the browsing or any app, if we feel any latency there, then it become a problem for us. And how we feel, we'll feel like an irritating, yeah, what is this devices and how it is being. So what are the organization will help us to overcome this? They will choose these type of computing measures like edge computing, so which bring all the things together and make the end user happy for that. So it also involves in deploying computing resources and and also reducing the reliance on centralized cloud infrastructure. So nowadays everything is everywhere. You see the cloud, cloud, cloud. So see how the days are going on. So before we used to have a storage device. Next, we came with some other alternate solution. And now, where our data is not able to store, we are bringing them all together into a cloud, and we are using that. So the importance of cloud infrastructure has came, and as well as all the organizations are getting importance of the cloud and their solutions into the cloud solution platform. So there we can implement this edge computing, where the end user and the client or the customers, whoever it may be, they'll be satisfied with all the possible ways they can move on. Right. So if I move to the next slide, let's discuss about the importance of edge computing in our modern digital landscape. So now, so if you see here, what we can talk about the importance. So the first thing is the latency. As I had taken example earlier during the time of definition. So latency is the major thing where we want to reduce it. If there is any delay, as a humans know, we won't be able to hold that and that gap of the delay things. So in order to reduce the latency, edge computing minimizes the data travel time and enabling real-time processing and quick response time too. So which help in the latency can be reduced as well. And next, enhanced privacy and security. Nowadays, it is most important picture for the privacy and the security. So here, the sensitive data, localizing and minimizing the security risks can be achieved with this edge computing. We can, but few challenges will be there. But we are discussing the importance, right? So here we have that importance because of this edge computing. So great. And next, the bandwidth optimization. Like edge computing reduces the need of transmitting large data volumes by optimizing the bandwidth usage. Right. This is the one of the most bandwidth optimization importance we need to look into. I think you agree with me. Yeah, definitely. You will agree with me. Yeah, great. So, next, let's talk about this reliability and resilience. So, what is here? What edge computing makes the importance here? It enables the function even with limited or intermittent network connectivity. So, we are facing a lot of network fluctuations nowadays. Maybe past also we had, but now, if network fluctuation is there, definitely we'll feel something uh, like we will feel somewhat uncomfortable during that time. So that also can be reduced with the help of this edge computing. So it's great, right? So let's talk about the next other importance. So which is like scalability, and as well as real-time decision making. So coming to this scalability and flexibility, what we can say here, it supports edge computing definitely supports the flexible resource allocation, and it is efficient in handling data volumes as well as allowing stability to it. So which 100% we are sure, and we that is very important in our communications or whatever it may be in our daily use. And real-time decision making. So it is one of the important thing where we require that the real-time decision making is important, where edge computing facilitates the data analysis and also the decision making crucial for this time period, right? So by here, it's clear that we have got the edge computing. What is edge computing and what are the importance of this edge computing? So let's move on. So before that, I would like to share you that you can follow us on our social media appearing on the screen. And this session is a part of the Global Devweek organized by Encora. And you can leave your comments, ask questions on the screen, or in the chat. Then I will be very happy to answer those questions. Thank you. And let's move on to the next session. Sorry, next slide. So let's see what is evolution of the computing. So in this, let's we will be saying that what is the traditional computing architecture, and after that how it came rise of distributed architecture and distributed computing and cloud computing, and now here the edge computing comes into the picture as a next level. So let's discuss about this in the evolution of the computing things, right? Let's come. Let's see there. So here we can see the both the differences, or else we can say that the things how we can see the traditional generalized computing architecture, what it is and how it plays. So if you see here, in early days, a computing, we can say that early days of computing, the predominant architecture was centralized, and they we used a single computer or a mainframe computer, we can say, to perform all the processing tasks, right? Which is a burden, or we can say it has a high load to that, and there is some latency and delay, or we can say some result which is not as expected. Hope you agree with me, I think here, right? So see, uh, this traditional, so we need to come out of these things, and we need to upskill it, like how we are daily upskilling with the new technologies coming. So that is the way this traditional centralized architecture, computing architecture also evolved, and gave the rise for the distributed computing and cloud computing. So hope you all are familiar with this distributed computing and cloud computing. Yeah, am I right? Yes, I feel we all agree with this. Why? Why? Because nowadays we are seeing. So, in not here we have distributed computing emerged as solution for these limitations of centralized architecture. So, in order to avoid this type of whatever the limitations or disadvantages or challenges, what we can say, to overcome that, we came up with this distributed cloud computing architecture. So what exactly we do here? We hear there is an approach. This is an approach which can improve scalability, reliability, and enabling parallel processing. So before, it is only one single system can need to give all the tasks and it should perform everything. But here, if you see, enabling the scalability, so distribute the work, and it can consequently or parallelly work the things. It can perform the processing and move forward. And what about this cloud computing future? So this cloud computing revolutionizes the computing landscape by providing the on demand. So definitely whenever we require infrastructure setting up on demand, it will be a difficult task. But when cloud came, it was very, very, very easy. Just if I think I need this resource, go in one click, we can get that. So that computing method, the cloud computing has given a very, very advantage over here. And it allowed all the organizations to scale their infrastructure dynamically. So however it may be, if we are getting the infrastructure and storing it away, we are having the cost, right? So where if you are not utilizing that resource, it is waste of money and waste of time and everything, right? So now if I go to the cloud, dynamically I can implement whatever I want. So whatever the resource I use, I will pay that. So definitely it is an vast advantage for the organizations, so where now all are moving in that way, in that direction. So right. So I hope it's clear about this traditional as well as how the distributed and cloud computing rise from here. Great. Let's move on. So see how this edge computing how came out of this computing evolution. Right. See here. While computing, cloud computing offers numerous benefits. Yes, it has limitations also when it comes to latency, sensitivity applications, and data intensive workloads. Definitely, we'll have some, whenever any re- revolution is happening and an evolution takes place, there definitely we have one of the challenges, definitely will have challenges. So that challenges will help us to rise and rise with this all these different things. So let's see in that way only where this cloud computing has some limitations. We have found some other solution where edge computing addresses these limitations by bringing computation and data storage closer to the source of data generation, right? Okay. So if I go on, so it in placing computing resources at the edge of the network and closer to the devices and the sensors generating data. So nowadays we are see if I take an example of the GPS, so where the GPS location, when our vehicle is going far away, so we need to track it. So how fast it is, like within seconds we are getting the tracking thing. Like suppose if I take one of the executives in somewhere in Hyderabad or Delhi or somewhere else, and I'm staying in other country, so I will get the data that your vehicle is moved from this place to this place. So how fast it is. So here it is bringing the closure the data. So it helps very well here, right? Yeah. So also the processing data locally at the edge computing reduces latency also as we discussed in the importance, and it also minimizes bandwidth usage and enhances real-time decision making capabilities, right? Yeah, great. See, and immediate responses as I give an example. So that's the way this edge computing came into picture, and IoT devices and critical infrastructure, everything can be helped and generated with this edge computing, right? Yeah. Hope we are good here. If you feel anything, if you have any questions, you're definitely ask us or the chat. I'll feel happy to answer those questions. Great. Yeah, this here. So architecture of edge computing. So how it becomes. So when I come to the architecture, as we said that it brings closure of the data and the storage and devices with the end users. So here if you see, we have three layers. One is a device layer, edge layer, and cloud layer. So all these are getting connected with this cloud is connected with the internet as well as the LAN, so on, what are the devices. So here, in order to make closure with the edge layer, with the device layer, so we are using some sensors or controllers where these devices will help in contact or close to the communication things what we are making. So where all this data will be collected at the edge layer, and where it gets processed and reduces the things whatever it may be, and it will finally provides us the result by moving it to the cloud layer, and where here the data gets processed, and we can say simply it as a data warehousing. So where all the data will be there and it can be processed, and it will the help of the devices, it will bring closure and give the result to the end user very efficiently, or right. As we are discussing, this is the main advantage of this edge computing, right? Right. So let's move on. As we already said, edge computing challenges, right? So let's see how the challenges are here. Right. See, what are the first challenge? I can take it as a network bandwidth, right? Yeah. So, what is the network bandwidth here? Why we are taking as a challenge? We already said edge computing will optimizes the bandwidth, right? Right. But if we know to optimize the bandwidth, the network should be continuous there, right? It should be no breakage should be there. So what it is, data transfer between edge devices and the cloud or data center, it should be continuous, no breakage should be there. So that is the cause of this challenge. So in order to overcome this, we have a lot of devices which we can continuously provide the bandwidth an optional way and alternate solutions, right? So next it is distributed computing. So what helps? So whenever it comes to distributed computing, network of edge devices and coordinating their computing resources to efficiently process analyze data can be complex, right? Yeah. So nothing is difficult possible, as we are saying it is a challenge. We are not saying it as impossible challenge. We are saying it as a challenge so we can overcome this distributed computing too. And latency, yeah, let's discuss this here, as we are discussing that it reduces the latency. But again, why latency came to the picture? It definitely we have a question. So let's discuss that thing here. So in latency, minimizing latency, it will be a critical challenge in edge computing. Why? As it requires processing data closer to the source requires efficient communication, right? So efficient communication must be there and timely response, and to ensure real time or near real time application requirements. So that is a definitely we say a critical challenge. So we can overcome this also. Definitely edge computing will help the us to reduce the latency, but it is a challenge for us. How? We can see in a better way of our optimization techniques things. So coming to the security here, security edge devices, right? As we say that now the security and encryption is most and most important. So here it is a crucial due to distributed nature of resources, where we are facing it as a challenge in edge computing. But implementing robust security measures and encryption protocols, it is we can protect sensitive information for sure, right? So here we go. Next, operational constraints. So what are these? Definitely the limited power storage and computational resources, and also constraints on deploying, right? So to overcome these, or else we can say optimizing resource utilization while meeting operation requirements will definitely become a significant challenge. Hope you agree with me, I think, right? Yeah, right. So data accumulation. So what it, or why it is a data accumulation is a challenge. So here a vast amount of data will be generated from these edge devices, and it should be effectively managed and processed. So in order to make these, it will be a definitely a bit challenging, right? Due to the resource limitations we have and intermediate connectivity to the cloud, right? Yeah. So this also can be overcome with efficient data filtering, aggregation, and storage strategies, where we require these things to overcome this challenge. Okay. So moving system constraints. So definitely we say it as, so now edge devices, whatever the for we are using the devices for edge computing, it should be adaptable to the dynamic network condition. So it is a big challenge for us. Whenever a dynamic regular network condition or changes were there, it becomes a challenging to maintain connectivity and synchronization and consistent service delivery, right? Yeah, so it is a challenge. Moving system constraints become a challenge here. And next, if I talk about unified architecture and release process, achieving a unified architecture and seamless release process, it will be both for cloud and edge, can be a complex. It's complex, not it is super complex, just it's complex due to the difference in infrastructure and how we deployment models and application requirements. That's make this challenge to be there, right? But see, for all the challenges, it requires a careful consideration and adoption of appropriate strategies, including network optimization, security measures, efficient data management techniques, resource aware application design. All these will help to ensure a successful edge computing implementations. Right? Right, great. So let's come here. Yeah. Great. Right. Before going to the edge computing case studies, I want to remind you once again, right? That this is you can follow us in our social media appearing on the screen as this is a session is a part of the global Dev Week organized by Encora, right? Yeah. Yeah. Let's move on to the next slide. Let's see the case study. So what it is. So the first thing I can check. Let's take it as edge computing in edge enhanced augmented reality, right? So augmented reality. Let's see the description. AR applications often require real-time rendering, content delivery, and precise localization to provide a seamless user experience, right? Yes. So what will be the use case here? Right now, by delivering edge computing, AR experiences can be enhanced. How? It is by offloading the compute intensive tasks, right? That is the way how it, such as it rendering and content delivery to edge nodes, right? Edge nodes closer to the user, so which will help to overcome, to optimize and to provide the enhanced solutions, right? Yeah, where when we bring these edge nodes closer to the user, definitely we'll have the minimizes the latency and network congestion and error experiences too. So, right, let's move on quickly with other things, other use case. So I can say it as real-time monitoring and alerting. So as I already discussed about this, so in IT, it definitely require the real-time monitoring and alerting. So in order to give efficient and enhanced service to our clients, it is definitely required, right? So here that comes into the picture, like edge computing devices, algorithms, or agents. We can use the monitoring agents, performing log analytics, and we can process the data sent to the central cloud-based monitoring system and long-term analysis too, right? Yeah. Let's move on to the next. Here it comes, integration CI/CD. Definitely, I agree. Most of you are familiar with this, and it's nowadays the CI/CD helped a lot to bring all the developers and team members, QA, everyone to closure. Once the developers it is deploying, integrating, it is continuous integration is going on, deployment process is going on, giving the results where the time get reduced and see if the team is working efficiently and giving the best and the good results there, right? Yeah. Right, future trends. Let's quickly move on to this. I can say it as Edge AI and ML and native application development, Edge security and privacy, as well as Edge data management, Edge DevOps, Edge analytics and insights. Right. When I speak about the Edge DevOps, I'll feel very happy. Why? Because as the work I'm working, right. So whenever these type of tools we are implementing in our technology, that makes very interesting and happy, and also we can give our best out of best with these edge computing devices, right? Yeah. So I conclude here with my session. So all this edge computing, it revolutionizes the computing architectures by bringing processing capabilities closer to the data source, right? Yeah. It also offers reduced latency, enhanced reliability, and improved security and cost efficiency. But only the thing is, we have few challenges which we can definitely optimize it and we can clear them, right? And we can provide an enhanced solutions. Great. And with this ability to enable real-time decision making and support IoT applications, edge computing is poised to transform industries and drive innovation in digital era. So hope we all will here with and we will implement these edge computing in our technologies and definitely we will do great innovations. Yes. Yeah, so I can give some references here. You can refer these. So not these are not the limited. We have an limited more as we can refer that. So thank you everyone for having here to have this session, and I'm very glad to present my things. Yeah, over to Asma.
Thank you. So, friends, embrace edge computing to unlock the potential of intelligent and connected systems. Thank you for this great session, Ashok.
Thank
There were really nice inputs, and I would invite all of you, my friends, to leave comments and questions on the chat, and our speaker will be delighted to read them and answer them. Right. Thank you once more for this session, Ashok, and I'm very grateful for those inputs. We hope to see you again in the future talks.
Yeah, that's
And
pleasure.
yeah, thank you. Yeah.
Thank you.
So, friends, thank you so much for your time. I hope you've enjoyed this talk with Ashok. And the next session will be starting now. Remember to return to the official websites and review the next session's agenda. Thank
Thank you
you.
everyone.
Hoping to see you soon.